Let's take a look first of all at n equals 2. Now we can quickly fail this one because we have two numbers differing by 1 that are adjacent. So that means that n is going to have to be greater or equal to 3. But if I put 3 in, 3 cannot be next to 2 or 4 because then they would differ by 1. It can't be next to 1 because it's odd. Can't be next to then, well, the remaining ones are then 5. Can't be next to 5. 3 can be next to 6. But that's only 1. It has to be next to two numbers. It can't be next to 7 because it's odd. So it could be next to 8. And what this means is that n is actually going to have to be greater than 8 for 3 to be able to follow the rules. So let's see if this is possible. Okay, I'm going to put 3 in first, and then I'm going to put it next to 6, and then next to 8. I've got the remaining numbers 1, 2, 4, 5, and 7. I just need to make sure that numbers do not differ by 1 and that even numbers can't be next to even and odd can't be next to odd. So let's take a look at 8. It can't be next to 7, 4, or 1, but it could be next to 5 or 2. So I'll put a 5 in. Right, now 5 can't be next to 1 or 7 or 4, so it's going to have to be next to 2. It seems to be working itself out from here now. Okay, 2. 2 can't be next to 4 or 1, so will have to be next to 7. 7 will have to then be next to 4, because it can't be next to 1. And 4 can be next to 1, which it can also be next to 6. So let's just summarize what we've shown. We've shown that it's not possible for 2, so we have to include 3. But then for 3 to be able to satisfy the rules, we're going to have to include 6 and 8. So n has to be 8 or more. That's quite nice. That puts a lower bound on it. And then we've shown that if we do put 8 in, just by carefully working our way through, then we can actually fill it. So there's no even numbers next to even numbers, there's no odds next to odds, and no numbers that are adjacent differ by 1. Brilliant.